Yeah, good evening, everyone. Switch on your hands. Let's start off. Where are the rest? People are missing. So, cams on, everyone. Hope everyone has gone through the notes. So this was the last thing that we did. Apparent depth and stuff. Who else? Why so many are missing? Okay. So next part is optical fibers. Again, a little bit of a theory there, and then we are going to do refraction on curved surface. So what are these optical fibers? So I'm sure you must have seen them, during a fair or somewhere. They would kind of look like this. You can actually break your internet cable now. You will find something like this. Yeah, if you break that, internet doesn't work. Let's say you have something which is a spoiled one. Yeah, this is how it would. This is a single fiber. You must have seen a toy like this. Ever seen these things? This thing you have seen, this bottom one. If you
Yes.
ever been to a fair or something, right? They keep a light here, and you'll see light comes out from these things. So basically, these are like optical cables here. So everything, internet, everything that you're seeing, right? The communication that is traveling nowadays is all through optical fibers. So even though when you think you're talking on a phone, the phone ka signal goes from your phone to the tower. From the tower, it goes through an optical fiber only. I think somewhere in 2010, right? Reliance people have installed 125,000 kilometers of optical fiber. That guy was way ahead of this thing. It was a complete plan for to take over for Geo. So today, when you use actually Airtel ka phone, the Airtel ka signal passes through Jio ka cables. They pay rent for using optical fibers of Reliance. So it is something of that sort. So there. So basically, an optical cable, right, has three parts. We have an inside material here, basically the optical cable, and then it is protected by some core, and then you have some cladding and plastering coating. So all that is just a supporting thing for this. Let's see how this works exactly. What is the concept behind it? And these optical cables, right? It is like a highway. This is how they're actually installed under the seawater. Ever thought about it when you do a phone call from here to, let's say, Europe or US, right? How does a phone call go? The phone call goes through a server, and the server, the signal actually sent through, underwater sea cables. This is how they would kind of look like. Mm, This is the map of, the world's optical cables. You must have seen Roadcar networks, now. Similarly, there are some special kind of ships, which lay down these kind of wires. So they are laid down under the water, and look at the amount of wires here. Huge number of wires between Europe and US. So whenever you make a call from India to this thing, right, the wires actually go through. here Dubai, from there they go to Europe, and from Europe to they go to US. That's if you ever made a Skype call to someone abroad, right? You will see there's a lag. You say like this hi kind of thing, and the screen is moving like this. So currently, when we are talking now, what is happening? Previously, now Zoom ka servers used to be in Europe and Dubai. The Indian government made a law like, if you are operating in India, your server should be in India. So previously, before this COVID and all, if I'm making a Zoom call, right, when I do like this, actually there would have been a lag. My hand would have moved little different slowly. You're getting it? So what was used to happen is when I am speaking to you, the signal will go from, let's say, Mumbai city to the Mumbai. From there, it will go to the C cable. It will go to the nearest server. And from there, again, it will come back to the signal here. That's what used to happen. So there used to be a lag of up to 1 second, meaning end of the day, it still travels with the speed of light. But now, because the servers are close by, so you don't find that much of a lag. It's like we call it latency. If there's anyone a gamer here, you will know this is the meaning of the word. Latency is like how much delay you have between executing a command and getting a reply there. Kind of. So there, if you see the C cables, right, this is what keeps all the internet together. By chance this underwater C cable gets cut, you're gone. You won't get any internet. Everything is shut down. You can't access YouTube, all that stuff. So what is the concept behind it? In 1990s and 1980s, right, getting a telephone connection was very difficult. If you have a telephone connection, you must be a very rich person. And I still remember, like, in our, even in 90s, 2000s also, right, early 2000s, we used to have these landlines. If you make a phone call, it was 3 rupees for 3 minutes. And 3 rupees was very expensive, huh? Meaning that time 3 rupees is now, think of something like 20 rupees. Whether you just lift the call and say hi, or you talk for 2 minutes 59 seconds, it is 3 rupees only. It is fixed. If it is 3 minutes 1 second, it is again 6 rupees. Right now, you guys don't pay anything for, we don't pay anything for calls. It comes as a package. But it used to be like that. It used to be messy. The reason why it used to be expensive, and this is all again, I'm talking in 1900s, only zamindars could afford a telephone connection and stuff like that. Means you should be a very rich person. The reason people used to use copper cables. And copper cable ka problem is this: you can send only one signal at a time. So just imagine you have this telephone exchange here. Your house is here. Your house is here. Your house is here. Everyone wants a telephone. Literally, one wire comes from everyone's house. And you know what they do then? Then we do something called interlapping. You will learn this in electronics communication if you're an electrical engineer. We have something like a grid, meaning I'm just drawing a very crude one. So this is house A, house B, house C, house D, house E. This is house 1, 2, 3, 4, 5, 6, 7. They're just different colors, nothing much. They don't really mean something. Meaning, maybe they can mean something, but it really doesn't matter. It is just to keep them differentiated. Maybe they'll use some for data, some for calling. They can differentiate it. So this is what will happen. See, let's say a person in house 3 wants to talk to person in D. Then this wire and this wire. So here you close the switch. This is what an operator does. If you ever seen an old movie, right, you will realize this. Operator connect me to so and so person. The hero calls or the villain calls. Right now, nothing happened. Right now, everything is automated. But once upon a time, there used to be people who actually used to connect the phone call. So when they say operator connect me to person D, then you have a plug kind of thing. You close this plug. So this wire is connected. So person 3 and D can talk. And let's say then at the same time, person 6 calls and says, I want to talk to person C. So this switch is closed. Let's say accidentally, person 7 also starts calling D. And this operator, without seeing, actually closes this call. So then 7, 3, and D, all three are in conference call. The signals will start getting lapped, and if this guy keeps his mouth shut, he can hear to the entire conversation. Happens in your house now. If you have two landline connections, if someone is speaking on the other phone, you can lift the phone and listen here. Kind of like that. So this is how it used to work. So problem iska kya hai na? Now just imagine in your apartment, there are like, let's say 50 apartments and everyone wants a phone connection. 50 copper wires will come from your apartment to the telephone exchange. Can you imagine how cumbersome it would be? And 50 copper wires means just imagine the weight of 50 copper wires on an electric pole. your entire streets will be filled with wires. It is a disaster. So getting a phone connection, it's very expensive, and copper loses a lot of energy. You need to put a lot of generators and everything. So what saved us is this optical cables. Optical cables have a different thing. So let's see how it works now. So optical, we used to use copper wires. We don't do that anymore. So when you have an optical cable here, this is the axis. Let's say this is mu1, outside is mu2. So you make sure mu1 is greater than mu2, so denser, and this is rarer. So you send a light signal at an angle I. Light has different frequencies also, so we can send a signal with different frequency. So once this light ray enters inside, something, I should make this more steep actually. So let this angle be R. So this angle will be 90 minus R. So if there is a TIR, this will bounce off here. So this also will be 90 minus R. So this light ray will come and hit here. So this also will be 90 minus R. So once you exceed the critical angle, the light ray will just keep on bouncing inside forever. So basically you're transmitting the signal because of TIR. So here from Snell's law, sin I is equal to mu sin R. We get sin R is equal to 1 by mu sin I. So, and we also know, so this is 1. Sin theta critical is mu2 by mu1. If 90 minus R becomes greater than theta critical, the light ray will undergo TIR. Total internal reflection. So this thing would be 90 minus R sin theta critical. So if you put sin 90 minus R should be greater than sin theta critical. This guy becomes cos R is greater than sin theta critical. And what is cos R? Root over 1 minus sin square R. And this would be greater than sin theta critical is mu2 by mu1. Substitute the value of sin R here. This is mu1. This is just a result. 1 by mu1 square sin square I is greater than mu2 by mu1. Square on both sides. Mu1 square minus sin square I by mu1. The root will be mu2 by mu1. Mu1 cancels off. You end up with mu1 square minus sin square I is greater than mu2 square. We get sin square I should be less than mu1 square minus mu2 square. So as long as this angle I is less than sin inverse root over mu1 square minus mu2 square, right, light ray keeps bouncing inside. So this way you can send the signal to the end of the cable without any leakage. So this is how you can send a signal through an optical cable till the end of the wire. Now, what is the biggest advantage of this? Let's say I got I is 40 degrees. So what I'll do, I will send one at 39.8, one I'll send 39.7 and 39.6. I can send 39.5 and so on. And the remember one of the property of light? If you have two light rays, they pass through each other without any interference. Means if you send 1,000 signals, all the 1,000 signals will go independent of each other without interfering. That means now in your colony, if there are 1,000 houses and everyone wants a phone call, I can just install one optical cable through the underground and I can give 1,000 phone connections. Generally, optical cable has a capacity of carrying 1 lakh connections. They have huge capacity. On top of it, what we do right now, right? We don't use everything for phone calls. We use most of it for data transfer nowadays. So without optical cables, right, the speed we are getting today, we couldn't have this online class. On a copper cable, if you try to have this class, it would be a disaster. I'll say hi and you will listen after 5 minutes. And there'll be so much dissipation. I will say, like, let's do it. Let's do this problem. You will hear let problem. You will keep missing the words. There'll be huge lag. It'll be a disaster. You couldn't play PUBG and all that stuff. Light ray carry information. Basically, light has a frequency. We can do that thing. We have a separate chapter called communication, which was removed from the portion. So yeah, you will never learn that in 11th and 12th. For example, right now when I'm speaking, right, my voice, it is called amplitude modulation. We convert, the voice into an electric signal, and we add that pura processor. We had a full chapter called communication systems. This was removed from this year. So if you take electrical engineering and engineering, you will learn that. Clear with this? So that's it. This is just a concept there. Nothing much in optical cables. But quite an important thing. Next one. We will wind up ray optics next week. And from Friday onwards, right, we will have a class. Friday ka class will be from 5:30. We are extending the time slowly. Wednesdays we'll have at 6. Fridays we will stretch it from 5:30 to 8. And later on Wednesday also will come 5:30. If you're getting tired, maybe I can give a 5-minute break around 7 o'clock. You can just walk around, stretch yourself, jump, and then come back to the class. Everyone got the box? Finished eating? Sweets are good? Anusha, you didn't get? Who didn't get? Abhinav, you didn't get? You filled the form? Rehan, you also didn't get?
Yes, I felt.
Oh, okay. Let me inform. I'll let Bruce know. Rehan, you got it. Okay. Oh, people who didn't get it, let me know, na. Point is, like, you might feel like, sir, it is okay if you don't get it. It is not okay. We paid the money for your transfer actually. So you won't get benefited. The shopkeeper just takes the money and keeps it with him. Those who didn't get it, so just message Vimi, ma'am. We'll get it done. Rehan and Abhinav, you both didn't get, na? Yeah. It must have happened. We sent almost 180 boxes, so. Clear with this? Let's see next one. So we sent it to your seniors now over an IITs. They're literally crying. Sir, why did you send it to the hostel? I said, what happened? My friends ate it already. The box came, the friends saw, they attacked it, and they ate it, and this guy was just staring. I said, yeah, survival of the fittest. IIT, mein, what are you expecting? Your friends will leave you. Actually, if IIT hostel, man, if you just throw 1,000 rupees, people might still think twice to take it. But you put a box of laddus or sweets, so you can say in a minute it goes off. Shamelessly, they will steal food. Money, people will think a lot like, nahi lena hai, it's wrong. Karke. But if you put food there, I don't know why. We don't feel it is wrong. It feels like it is our right to steal food from our friends. So you have to be very careful. Next thing, refraction on curved surface. In my hostel, we used to have a guy called Jagaraj. This guy has a habit. He sees someone eating, he'll steal it from their hand. He'll just snatch it. Initially, we used to get pissed off, but theek hai, abhi kya karna hai, na? Because this guy, once in a semester, he used to bring a lot of food. Jagaraj used to bring literally like 20-30 kgs of food from his village. Huge. Literally, it is like he used to leave the room open, door open, and say, those who want, you can eat. It used to take us almost 1 to 2 days to finish off all that food. People literally used to jump into his room, take whatever they want, and eat. It's not different things he used to bring. So when he used to steal, we used to be like, chal na yaar. He used to feed us so much, they let him steal types. So one day, right? Some guy was eating a biscuit. A monkey came, he got scared and threw the biscuit packet. The monkey was eating it. So then we came with a hockey stick, monkey ran away. So this guy took the biscuit packet and he was about to throw in the dustbin. Jagraju was walking by. Usko kya laga? This guy is eating. He snatched that biscuit and started eating. And we are looking at him. So monkey actually ate half the biscuit. This guy ate the other half. We didn't tell him till next day. So you have to be careful when you're snatching. You should know whether you're eating or a monkey is eating. So refraction on a curved surface. If you see last class, what we did was refraction on a plane surface. So again, we won't need all the derivation is not important. So mu1, mu2 are the reason derivations are not important because you use a lot of approximations. So it really doesn't matter. The derivation is there in 11th standard HSC. So HSC में 11th है ही नहीं, so we can ignore it. So if you send a light ray from here, and let's say this thing meets somewhere here. This is the formula. Do copy it down. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. So this is the formula here. And magnification. M is given by minus mu1 V by mu2 U. So here mu1 is the medium of the incident rays. So it is important to know who is the object and who is the image here. Mu2 is the medium of refracted rays. Quite an important formula. Again, remember everything U, V, and R should be taken with sign convention. It's the same sign convention we used before. And remember, object should be on the principal axis. We did the same thing in mirrors also. If it is above the principal axis, you know what to do. We drop a perpendicular, then we find the foot of the perpendicular image, and then we extend it. Do copy down these two formulas. So theory-wise, that's it. That's the thing. So let's see some problems on this. We have two people missing. Who are these? Clear? Let's see a question. You can start doing your booklet or this HCV for this chapter now. Maximum things will be getting over. Like we'll be starting lenses also next week. Mostly this Friday. Next week we'll finish off optical instruments and everything. Where did they reach till ray optics? Did they finish off in PACE? Going on?
So they have to start refraction.
Okay. Yeah, but I think they're ahead in Centrum Mass, na?
Ah,
That will always happen. We will go one chapter ahead, they will be one chapter behind. I think, okay, some people lenses have started. Okay.
so we finished lenses.
Okay. Okay, na? Let's see what they'll do for the major test. I don't think they'll keep thermodynamics. Even last year they said thermo, but they never kept it. Let's hope. 32. Let's see a question. So let's say mu1 is 3 by 2. Mu2 is 2. The radius of curvature is 20 centimeters. Object is here. 30 centimeters. Find the position of the image. Object is here at a height of 1 centimeter. This is 10 centimeter. Find the position of the image. Like I said, optics, you should know your sign convention and the formula. What is the formula? I hope you note it down. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Mu1 is the medium of incident rays, and mu2 is the medium of refracted rays. R is the radius of curvature. And the direction of incident rays is taken as positive. That's the convention we use. Try. You got 2 minutes. Got an answer? Do type in the chat box here. And do keep your cams, everyone. Do keep your cams on. Okay. We have 2 answers, 40 and 80. One of you is definitely wrong. Do check. Okay, we have 2 minus 80s. So that might be right. Aisha, check your answer. We have 2 80s. So oh, we have 80 by 3. We have 40. We have 2 40s, 2 80s, and 180 by 3. So I'm not sure what is the answer anymore. Try. I'll give you another 30 seconds and I'll show you the first one. We have 280 by 3s, 2 40s, 2 80s, 280 by 3s. Interesting. I hope everyone tried the 2 practice papers. I know there was an issue with this multiple choice. I'll get it sorted out. But anyway, like I said, those I'm not putting any results or anything on that, so don't worry about it. It's just for practice. I think multiple choice mein kuch ho gaya. I think we have more 80 by 3. So let's see how to do this thing. The important thing is your sign convention first of all. So what is mu1 here? I should not have written mu1 and mu2 here. Simply write mu and mu. So mu1 is 3 by 2. Mu2 is 2. Radius of curvature is minus 30 because the right side is positive. Center is on the left hand side. U is minus 30. V, I don't know. Please check. If you had messed up any minus sign here, because see now, how are the light rays going? Light rays are going this way. So this is positive. How is the center? Center is on the left hand side. So radius of curvature is negative. Right? Remember how to take radius center sign convention for radius of curvature.
So you gave
So,
R as 20.
Yeah,
right?
isn't R20?
yeah, 20. Sorry. So now apply there in the formula. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. 2 by V minus 3 by 2 minus 30. 2 minus 3 by 2 by minus 20. How much is this? 2 by B, 1 by 20 minus 1 by 40. This goes that side. So we'll get 2 by V is minus 3 by 40. So V is equal to minus 80 by 3 centimeters. Meaning the light rays are going like this. They're actually diverging. And the image forms here. It's a virtual image. Yeah, 80 by 3. Please check. See where you messed up. Now can you do the B part? Now remember B part, you have to get magnification also. 32A. Anyone is not clear, please ask. Let's see. Fifteen and 1. Mu1 is 4/3. Mu2 is 2. R is +10. U is -10. Applying the formula mu2/v, so 2/v minus 4/3 minus 10 and 2 minus 4/3/10. This would be 1/15 and 2/15. This guy would be 3 to 6. 4 2/3 1/15. So 2/v is minus 1/15. So v is minus 30 centimeters. Am I right? And the magnification is minus mu1 v by mu2 u. You need to mark up the formulas. 4/3 minus 30 by 2 u is minus 10. This guy would be minus minus plus. That is 40/20, so minus 2. So that means the image, right, is forming 30 centimeters behind somewhere here. And minus 2 meaning it is inverted. Two centimeters below at a distance of 30 centimeters. Meaning these light rays now from here were actually it's also a virtual image. Have a look at this. Yeah, right. Minus 30. So the coordinates would be like minus 30 minus 2 centimeters. Is that clear, everyone? Can you see the process looks similar to mirrors, only the formula is different? Ali, clear with this? Clear, na? Yeah. Niranjan, Vidyut, clear with this? Palaksh, Mehan, Maulika, got it, na? Swastika, Rehan, clear with this? Great. Next one.
Sir, won't R be +10?
+10 नहीं लिया ना मैंने?
Sir, radius of curvature.
10 only,
No,
na?
no, say.
I took 10 only. Clear? Next one. There, I hope you got the hang of the formula now. So we have a glass sphere. Radius is R. Refractive index mu is equal to 2. Outside is 1. We kept an object here at a distance R. So what will happen? Light rays will hit here, then they'll fall somewhere here. The light rays will hit here and they fall somewhere here. So there'll be 2 refractions. The observer is standing here. That is one case. Second case, same scenario. Mu is equal to 2, but this time you silvered the sphere. Object is here at a distance of R. Find the position of the image. Now, whenever they say find the position of image, meaning the image which forms after all reflections and all refractions. मतलब उसके बाद light rays were not supposed to undergo any phenomena. So if they say find the position of the image, that's what they mean. Example, listen to this thing. Look at the third case. Light rays will go here. What phenomena is this? Refraction. Then they'll go and hit this thing. Then what is this? Reflection. Then again they'll meet here. Then again we'll go through this. Again refraction. And finally they're gone, right? Forever. So there's a refraction, reflection, refraction. So 3 phenomena. Get them both. This was a good question. I can ask this as a paragraph. Both are connected though. In the exam, if I have to ask you, I'll ask the B part directly. Find the position of the image. Generally, the meaning is image formed after all reflections and refractions. Let's get this. Hope the question was clear. Anyone confused with the question, please ask me. First one is an interesting answer. Answer comes in terms of R. 4R from object. Yeah, that is right. Adrit. I know you guys got confused in the first part only. You got the answer, but you guys are not able to interpret what it means. Let me show you the first part. See. So this is your first refraction. Object is here. The mu1 is 1. Mu2 is 2. Radius of curvature is plus r. U is minus r. Apply the formula. 2 by v minus 1 by minus r is equal to 2 minus 1 by r. So we get 2 by v plus 1 by r is equal to 1 by r. That means 2 by v is equal to 0. This implies v is infinity. What is the meaning of this? The light rays have gone here. Think of it, the meaning of it. V is infinity means what? Image forms at infinity. Means light rays have become parallel, na? Parallel light rays will meet at infinity. That is the indication of that. So once after first refraction, the light rays have become parallel. So these light rays are going parallelly and hitting this surface here. Then we have second refraction. Now for the second refraction, getting it, mu1 is 2. The incident medium is, these are the incident light rays. Mu2 is 1. Radius of curvature is minus r. U is infinity. So apply in the formula mu2 1 by V minus 2 by infinity is equal to 1 minus 2 by minus R. This is anyway 0. So we get 1 by V is equal to 1 by R. So V is equal to R. Meaning from this point, they will meet here at a distance R from here. So the image forms at what distance? 4R from the object or R from the other side of the sphere. Making sense? Actually, you could have guessed it, once the light rays become parallel, by symmetry, we know if the light rays become parallel rays will again form at R. You can see that there's a symmetry. There's no need to do the second part actually. But then again, so I showed it to you. Please check what I did. So we have to apply the formula repeatedly 2 times. First refraction, second refraction. And the distances are always measured from the respective poles. So be careful. This is P2 and this is P1. So the final answer we got R is from P2. Plus indicates it is in the forward direction here. Clear, everyone? Now can you do the second part? What if you have the right side is silvered? Same question, the right side is silvered. Now what? Try, I'll give you another 2 minutes. So first part is already done actually. So half of the problem we already did. So you silver this right side. Find the final image.
So can you put the question?
Hmm.
Yes, okay.
3R by 4. Okay, let's see. 4R, 5R by 2. I'm not sure. We have to check. So look at the B part. So we have first refraction. So this we already did right now, so we'll not do it again. Light rays will become parallel. Then reflection. So these light rays which are parallel, where will they meet? If you send parallel light rays on a spherical mirror, they meet where? At the focus. That will be distance of R by 2. Yeah. Then now the light rays are coming from this point here. So this will look like the object here. You have again second refraction. This is how you do. Like all problems, right? You do one step at a time. When you talk about reflection, don't talk about refraction. When you talk about refraction, don't talk about reflection. So light rays are going from right to left. So applying the formula, mu1 is incident light rays, which is 2. Mu2 is the outside one, 1. Radius of curvature is minus r, because left is positive, but the center is on the right hand side. U will be minus 3r by 2. Distances are measured from the respective poles. So this is 3r by 2. Apply the formula. Mu2, like I said, if you observe, right, the main thing is sign convention. If you mess up one minus, then the whole thing goes for a toss. And then apply the formula properly. 1 by v minus mu1 2 by u minus 3r by 2 is equal to mu2 minus mu1 1 minus 2 by minus r. 1 by v plus 4 by 3r 1 by r. This would be 1 by v is equal to minus 1 by 3r. V is equal to minus 3r, meaning these light rays have become something of like this, and when you extend them, you're getting a virtual image at a distance of 3r from this pole. Check it out. It's a virtual image. See, this is how you know whether an image is virtual or real. If the light rays are actually meeting, you should have got V is plus 3r. Because you're getting minus 3r, meaning the image is actually forming behind. Please check.
Sir, in
Hmm.
1 by r, when we subtract it. Okay, sir, got it.
What I sent you is from the object. Okay. 3r. Okay. Okay. Then it is right. Fine. Please check the steps. It's not a tough question, but it is like you have to do it systematically. Repetitive. Clear? Next one. Any doubts on this? Anyone not convinced with this, please ask. Mehan, keep your cam on. Venkatesh, Ronak, Abhinav, cams on, everyone. Next one, this model is important. You have a slab like this. This side is silvered. Radius is 20 centimeters. This side radius is 10 centimeters. This is the principal axis. This is the object at a distance of 40 centimeters from here. This distance is x. I don't know how much is this. The question is find x if the final image forms on the object itself. Let's get this. It's a good one. It's a pretty good model actually. You will see a lot of questions, of this type also. I can put a slab, lens, mirror. They can ask you this kind of questions. The hint in this question is this.
What is mu?
Mu भी देना है ना. Let's say mu लेते हैं 3 by 2 ले लेते हैं. Outside is 1. So when you see these kind of questions, see this word should hit you. Final image forms on the object. The moment you hear the word, you should strike like boss. मुझे ये करना है. What to do that? Let's figure it out. Like I keep saying in physics, right? There are certain words when you hear, you should get alert. One word is what? Distance. When you hear the word distance, it's a trap. The body might be turning back. Or when they say friction and equilibrium, meaning you'll get a range of values. You don't get a single value because friction is adjustable. So final image forms on the object. So similar things. What do you guys think? Right, Aryan, get them? Interestingly, there are two answers. I don't know whether you figured it out or not. This will be a good multiple choice question. Most people get one, and the second part, it doesn't strike normally. Okay, let's see. So first thing, when you hear the word, what is the first thing that should come into your mind? This implies the light rays must have hit the mirror along the normal. That is one possibility. Remember principle of reversibility? We did this question in the beginning. This question, if the light ray hits the mirror along the perpendicular, it will retrace the path. So if the mirror thinks object is at the center, then the light rays will go back the same way they came. That is one. There is also a second reason. We will see what is that. First, let's see the first part. First, find the image. First refraction. I'll stop writing mu1, mu2 now. Directly, you should know how to write 3 by 2. V minus u mu1 is 1 by u is minus 40. Mu2 is 3 by 2 minus 1 and r is plus 10. This is 3 by 2v. That's 1 by 20 by 1 by 40. So 1 by 40. V is 60 centimeters. Got this? That means these light rays are hitting here. And the image here is forming at 60 centimeters. This is clear. Now look at here. Now there are two possibilities that can happen. Case one, the image, let's call this thing I, image I is at the center of the mirror. So in this scenario, this is what would happen. The light rays would start from here. They go and fall on the center. So if the light rays fall on the center, what will happen? They'll go hit the mirror along the normal. They will retrace the path, so they'll come back again. And again, they'll form the image. So basically, light rays will retrace the path. So how much is this distance? 20 centimeters, radius of curvature. How much is this distance? 60 centimeters. We just now proved. Therefore, x is equal to 80 centimeters. This is one option. You know what is the second possibility? Image I forms on the pole. This is a case where most people forget. What happens, interestingly, see, if this is the object, this light ray which goes up, if it hits the pole, we know this light ray will again come back here and like this. They will reverse actually, up and down will get reversed. The light ray which went from below, when it hits the pole, this will actually go in the opposite direction, will come back here. The image will form here only. Are you getting how it forms? Because these two angles will be equal now. If you hit the light ray at a pole, that theta will be same. So this would be the image here. So in this case, this is 60 centimeters. So this is the second possibility. So there are two options here. Light rays hit along the normal or at the pole. Please check this thing. There are two answers, 80 and 60. Most people get the 80 part. People forget the 60 part. Right, Adrit. Is this logic clear, everyone? If you want the final image to form on the object, the light rays should retrace. They should come back in the same way. If the image forms at the center, they will retrace properly. But pole is a special case. If they hit the pole, up goes down and down goes up. How will you remember the cases during the exam? Now you know. Isn't that what you're doing in the class now? You're learning it. Now you know, right? So next time whenever you get a question like this, understand there can be two possibilities. You got 60, you didn't get 80 part. Yeah. Now it's understood, right?
Sir,
Palaksh, clear with this thing, no?
so whenever the image is formed on the object, like there are two cases.
Yeah. Normally, सोचा अगर प्लेन मिरर है तो एक ही केस होगा.
Okay, हाँ.
Plane mirror, तो then
Actually,
plane mirror also you can have one case only because in spherical, you're getting two cases.
half a spherical.
And कोई guarantee नहीं हर बार होना चाहिए. For example, सोचो this image I ना, if falls something like here, then तो you're gone, na. So there are possibilities. Or what if this image which forms here is virtual? Getting it? So there is no guarantee it can form, but maximum two answers you can get. Maximum two answers. All clear with this? Haan, Palaksh, clear with the logic, na? So it is like that only. Think about it, na? Chemistry, when you mug up some statements, how do you remember? You learned it, that's why you remember later on. So now you know there are two cases. Next one. I hope you can see the resemblance. It kind of looks like mirrors, but the formula is different. You're just playing around with the same thing. Let's see how will you do this thing. So we have a surface here, R is 20 centimeters. Mu is 2. Mu is 3 by 2. We have an object here at a height, which is going with a speed of 2 centimeter per second at a height of 1 centimeter at a distance of, let's say, 20 centimeter. I can take 20 centimeters. So let's take 40 chalega. Find the velocity of the image. We have done this in mirrors. This is the third case directly, the complicated one. The object is going above the principal axis. How do we do this? Again, this is what happens if you try to remember the formulas instead of the process. If you remember the process, whenever you need to find the velocity, this is what we did. What was the process? Get the equation. Now the equation has changed. Differentiate it. That is the process. You know the equation, differentiate it and get it. So you will get a new formula now. This formula is not valid for this. This formula is valid for mirrors. Try. Take a minute more. Yeah. Take a minute more. Try. Anyone confused with the question, please ask. This we did in mirrors. That's what I'm telling you. Do make sure to revise the notes. You will see a lot of similarities. You don't keep learning new things. You just learn one or two new things, and when we add it up, things become quite different. If you think everything is new, you will get overwhelmed, and physics will look like hopeless. But if you think everything is simply an addition, it looks more easy. Then to give a simple analogy, think of like this. You have dosa, you have masala dosa, you have Szechuan masala dosa. See, it is dosa only. You're just keeping adding more and more ingredients. It becomes more complex. So if someone asks you to do masala dosa, you just have to make a plain dosa, put some potato curry and just stick it and you're done. But if you tell them everything is a different dish, it gets scary. Onion dosa, make a plain dosa, put some onions and you're done. See? Always think of like that. We get an answer 32. There'll be two components, right? I cap, J cap, remember? Since the object is going above the principal axis, we get two components. I'll just show you this problem for reference. You won't get an easy one. This guy. तो horizontal तो ठीक है, that you'll get it from direct differentiation. Vertical के लिए you have to differentiate magnification, remember? You get two components, I cap and j cap. This would be a proper advanced paragraph question. Try. I'll give you another minute or two. I'll show you the horizontal part. Try for a minute more. Let me help you with the first part. So the formula is mu2 by v minus mu1 by u is mu2 minus mu1 by r. Differentiate with respect to time. Okay. So this formula becomes minus mu2 v square dv by dt. Hope you remember the differentiation. This is mu1 by u square du by dt. This would be mu2 minus mu1 by r square dr by dt. Luckily here radius is not changing here. So this term is 0. You end up with dv by dt is equal to mu1 v square by mu2 u square du by dt. This is your formula. This is velocity of the image with respect to the pole. Mu1 v square by mu2 u square, velocity of the object with respect to the pole. That's your formula, everyone. Now from here, if you can get this data here, I'll do one thing. I'll just calculate the v ka value from here. 2 by v minus 3 by 2 minus 40 is equal to 2 minus 3 by 2 by 20. 2 by v by 3 by 80 is 1 by 40. 2 by v minus 1 by 80. So v is minus 160. Perfect. Magnification is minus mu1 v by mu2 u. u1 is 3 by 2 minus 160 by 2 minus 40 minus 3 minus 3. Magnification is minus 3. Great. So now apply in the formula here. So velocity of the image, but remember this only gives you the horizontal component. Or component along the principal axis. The velocity of the image mu1 is 3 by 2, mu2 is 2, v is minus 160 ka whole square minus 40 ka square, and the image is going with 2 centimeter per second plus 2 centimeter per second. So this would be 40 square, so that is 4 square 16. 16 by 4, 4, 3, 12, 24 centimeters per second. Okay. Am I right? Did I goof up? Anyone got 24? 40.
I got minus 20.
Minus कहाँ से आया करे? यहाँ पे तो minus है ही नहीं. And u became squares, ना? Yeah, forgot multiply by 2. Okay. अरे minus आने का chance नहीं है ना? Check करो. Remember, this is the horizontal component. Please check the steps. So first you have to find v ka value. Uska to kuch, you can't do anything, you have to find. And then differentiate this function and substitute the values there. Exact same thing we did in mirrors also. The only difference is formula has changed. Please check the steps. Clear? The second part. We have to differentiate magnification, which is minus mu1 v by mu2 u, which is height of the image by height of the object. So velocity in the y component will be dhi by dt. That would be minus mu1 height by mu2, then v by u ka differential. Mu1 ka value I know, mu2 ka value I know, h ka value I know, and this differential will be v minus v by u square du by dt plus 1 by u dv by dt. That's your y component here. So substitute the values here, minus 3 by 2. 2, height of the image is 1 centimeter. V will be minus 160. U square is 40 square. Du by dt is plus 2. U is minus 40. dv by dt is 24. Brute force. Like I said, it's a brute force. Substitute everything there. This would be minus 3 by 4. 40 square will be 1600. So that is minus 2 by 10, minus 1 by 5. And that would be 4 tens are 4 6. So 6 by 10 multiply 2 to minus 3, 8, 3, 24 by 40. Minus 8 by 10, 8, 3, 24 by 40. So 6. 4 tens are 4 6. 6 by 10 to 0.6 centimeter per second. Plus indicates upward j cap. So therefore velocity of the image will be 24 I cap plus 0.6 j cap. 1 by 5 माइनस ना माइनस और माइनस प्लस हो जाएगा ना ये शिट रे देन कितना होगा ये 2 by 10 2 minus 6 minus 4 by 10 4 4 will cancel 0.3 माइनस आ रहा है क्या प्लस ना or minus plus so you know how will the diagram look like this was the object here going this way with 2 centimeter per second this was 40 centimeters the image is behind 160 centimeters magnification is minus 3 so this is 3 centimeters below here this has a velocity 24 centimeter per second this way this is 0.3 centimeter per second this way so the object image is actually going this way 160 centimeters, and this depth is 3 centimeters. Clear? How is the velocity?
So 1 minute.
Please check. Yeah. Please check the steps. Clear. Next one. Now, if they want to really play around, they can do something like this. We have a sphere and we have an observer inside. The sphere refractive index is changing with 1 plus t. T is time. U is not constant. So we have a sphere with a variable refractive index. Radius of curvature is r. We have an object here at a distance of 3r. It is at rest. Outside is mu is equal to 1. But sphere refractive index is changing. Find velocity of the image at time t as seen by the observer. So if you try to mug up the formulas, you'll get trapped like this. You should know how to start the problem. You take the basic equation and differentiate. So every time the body need not move, I can change the refractive index and make the image move. Body is at rest, image is moving, but get this. These are the kind of questions you can expect in advancement because they're not tough, but when people say this thing, first thing they get into a shock. What the hell, karke? So main thing is that you should get used to that feeling like, okay, question looks weird, but we just need to go back to your basics and handle this. If you can just save yourself from the shock, most of the time you'll be able to handle the question. You know what is the biggest problem people have when they fall into a cold water? India में नहीं होता है because here temperatures never go below 20 degrees. But when you're in a cold countries, right, most people, right, when they fall into a water, even good swimmers also they die. The reason when they hit the cold water suddenly, your body temperature is 36, 37. Water ka temperature, let's say 0 degrees or 3, 4 degrees. The sudden change in temperature makes them go into a shock. It takes them 30, 40 seconds to respond. By the time they will sink or the temperature, they'll become too cold. They'll get a frostbite and everything and they die. So the most important thing is when you fall into the water, be conscious saying like, boss, the water is just cold, but I can handle this. If you can get out of the shock as soon as you can survive. Same thing happens in advance also. You see some weird question, people start panicking. But you need to understand the examiner knows the question is weird, out of portion, or it is a little thing. So he must have given you the question with the sense you can handle this in 3-4 minutes. That means question mein kuch hai. If you can see carefully, you'll find an easy way out. Or you should be clear with your basics. Again, don't treat studies as if it is different. Living a life, studying, cooking, everything is same. There's no difference. Think about it. Been to Imagica? There Aqua Magica, there's a ride. You go there and stand inside and the door suddenly opens. And you just fall down. Been to that ride? You know what is the most scariest part of the ride? It is not the ride. It is waiting for the door to open. Isn't it? You go inside and you're just standing there and you're getting scared, anticipating door kab open hoga. Once the door opens, you don't even realize when the door opened. You will just skid and you'll come out in a less than 10 seconds. My voice is coming weird. My voice is fine. Anusha, your speakers don't like me. Do something about it. It's better now, Anusha? No? Still weird. I think how is it sounding like we are going to conquer this world? Something like that it is coming? No. Robotic are okay. I just spoke like that actually, so what? How to do everyone? Chalo, let's try this thing. I'll give you a minute more. The story starts from here. Take this function and differentiate. So let's see what changes in this. Take a minute. Just give it a try. Just get some water and come. Well, my answer doesn't come great anyway. Let's see. So take your function. Mu2 by v by mu1 by u is equal to mu2 minus mu1 by r. So here mu2 is 1 plus t, that is changing. This is 1 by u is constant. How much is that? Minus 3r. This is 1 plus t minus 1 by r is r only. So 1 plus t by v plus 1 by 3r will be t by r. Differentiate. This differentiation is a little messed up. So it is like u by v ka differential. One plus t d by dt of 1 by v plus 1 by v d by dt of 1 plus t. 3r is constant, so that will be 0. R is constant, and that will be dt by dt. So this would be 1 plus t minus v square dv by dt This would be 1 by V, and that is constant 1. This would be 1 by R. So from here we get dV by dt will be 1 by R minus 1 by V. And that will be V square by T plus 1 with a minus sign. Yeah, numbers are given. We can just substitute and finish it up. Can we take on one side and keep on? You can do that also. You can bring T on one side and differentiate. वो भी कर सकते हैं. You get the same thing. But so you have to find V का value and dump it here. It's okay. Leave it here. Numbers are given. You can handle it. I just want you to know, like, question जैसा भी होगा हर बार, objects won't move. You can change even mu also. Have a look at the process. Anyone not clear with the steps, please ask. Ronak, clear with this? Udian? Clear, na? Mehan? Got this? Venkatesh? Clear so far? Great. What if mu object mu's in, then object mu karega kya hoga? You can't write this thing u, na? This also will get 1 by u square du by dt. That'll get more messed up. You just get more variables, aur kuch nahi hai. Image will not form initially. Image T0, it will become little weird. The T0, the object only will look like image for that person. There'll be no refraction. No? Initial refraction index will be 1 everywhere. Clear? That's the refraction on curved surface. Then what will be V? V will be U only, I guess. It actually becomes undefined, right? Defined nahi hoga. There's no refraction only. We can't use that formula. Great. Next thing. Lenses. So refraction on curved surface, it is that main one formula there. So what is a lens? Basically thin lenses. We study thin lenses. A lens is made of a transparent material. With at least one curved surface. So when you take lenses, so this is your principal axis. This is your biconvex. This is biconcave. This is convexoplano. So left side is convex, right side is plane. This is plano concavo. This thing left side is convex, right side is concave. So convexo concavo. Naming is fine, not a big deal. Depends on which way you're seeing first. So here we don't call it optical pole, we call it optical center. And here, T is the thickness of the lens. R1 and R2 are the radius of curvatures. So when you take a lens here, so when you say a lens is thin, so what do you mean by thin lens? for thin lens, the T should be much less than R1 and R2. Example, let's say radius of curvature R1 and R2 are 10 centimeters. Maybe the lens ka thickness is something like 2 millimeters. So that's the meaning of, very thin lenses. And same thing, if you remember, this is your aperture, the same idea there. This is your thickness. You know what is an aperture? Aperture is the region where the light ray enters. We did in mirrors, it's the same idea there. Have a look at this page. Clear, everyone?
So what is the advantage of a thin lens?
You will see. We'll get a good formula. If the lens is not thin, then we have to use this thing, refraction on, for example, see, this was not a thin lens, right? Thick one.
Yeah.
So then you have to use refraction on curved surface. When the lens is thin, your life becomes a little easy. We'll see what is that. Now, we define something called focus. This though we defined before also. But focus ka definition is, if you send, focus can be defined for any system. When parallel paraxial rays are incident on a system. Now, that system can be mirror, lens, mirror and lens, it can be anything. The point where they meet or appear to meet is the focus. Now, remember, unlike mirrors, lenses don't have center of curvature. So if you take a lens like this, or if you take a lens like this, so if you send light rays here, they meet here. So this is the focus. This is your focal length. If you send light rays here, they diverge. And when you extend them, they meet here. So for this, the focus is behind. And in lenses, we have some special light rays, just like mirrors. If you send a parallel light ray, it will pass through the focus. If you send a light ray from the focus, it will become parallel. So a lens will have two focuses actually, depending on which side the light rays are coming. If you send a light ray through the optical center, it goes undeviated. This point 2f is special. This thing behaves like center, but it is not center. If you send a light ray to 2f, it will pass through 2f on the other side. Later on, we can prove this with an equation also, but yeah. Check it out. These are the 4 important light rays. So using this thing, we can trace the images. Remember, we did in mirrors for different positions, object is at beyond center, blah, 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 all that stuff. So same thing we'll do here also. Clear with the steps? Great. Let's see. So if you look at the image formation, this is the tracing basically. Look at this for convex lens. If you send parallel light rays, the image will form at the focus. It is real, inverted, and highly diminished. If the object is beyond 2f, the image will form between f and 2f on the other side. It is real, inverted, and diminished. Please have a look at the statements. Clear? Next one. If the object is at 2f, image is at 2f. This is an important statement here. This is the minimum distance between object and image. Think about it. If you try to bring it closer, the image will go away far. If you try to bring it far, it will get closer. The least distance you can get is this. And there's no concept of, center for lenses. So 2f behaves like that, but it is not the center. The real image and real object. That would be a good theoretical question. Find the minimum distance between an object and image in a lens. Have a look at this. Yeah. Have a look at these two. If you are between f and 2f, then the image will be on this side here. So here the image will be is beyond 2f, real, magnified, inverted. Please check these things. They look quite similar to the mirror thing which we did. Turn in the page. So if you're exactly at focus, image will go to infinity. If the object is between focus and pole, you'll get a virtual image. This is quite similar to concave mirror results if you see. It looks quite similar. Have a look at this. Clear? And then when you try to draw for a convex mirror, by concave, we have only two cases here. Just like convex mirror. Object at infinity, image at focus, highly diminished, and direct. If you keep the object here, this will go like this. This would go like this. When you extend this, the image would be, wait, it's focus piche na, it would go like this actually. I'll magnify this a bit, wait. This will go through the principal axis. This would go like this. So when you extend it, this would be the image. Virtual. Image is diminished. Virtual, diminished, and direct. Just like convex mirror ka formula. Check it out. This thing is similar to convex mirror. There is a resemblance. Clear, audio? Then if you try to look at the graphs, these are the graphs. We have done similar graphs in mirrors also. Check out the graphs. Same thing. So object is at infinity. The image will try to form at the focus here. As you get closer to this pole, the image will go to this thing at focus infinity. This is the pole here, red point. This is your X and Y axis. So the graph is like this. So this is the point of that focus. At the pole, they both meet, and again, this will extend. Same graphs, we check it in mirrors. Do check it out. Graphs are important. So there we have a convex lens and we have a screen. candle is our object here. Music is nice. So you took a focal length f1 is 20 centimeter, 2f1 is 40 centimeters, 2f. So there are two focuses on the either side, depending on which side the light rays are coming from. So lens, you can see the setup there. So lens, focus on left hand side, right hand side, 2f, 2f on both the sides. So for a lens, you have two focuses and two 2fs here. Candle is your object. Case one object is very far. 2f, f. So here very far, matlab like 2-3 meters. You can see the image, it forms at the focus on the other side, little dot inverted. It forms at f2. You keep it beyond 2f1. So you have to move the screen little behind between f2 and 2f2. There you can see the image more clear and clarity. It is inverted, the flame is pointing downward. So this is what do you mean by capturing the image on the screen? Heard that statement, right? You can capture the image on the screen. Matlab, if you put a screen, you can see the image. And you have to keep moving till you get a very clear image. Case 3, you keep it at 2f1. You get at 2f2 on the other side. Same size. Inverted. There you can clearly see the image there. Image is the flame we are talking about. Now you are between f2 and 2f2. Image is magnified. It is beyond 2f2 now. You keep it at focus. Image, you have to keep the screen very far. And you can see the image, it is very enlarged, huge. When we say screen is very far, we just talk about maybe 3-4 meters here. You really can't keep it at infinity. There it is big. If you keep it between f1 and f2, f1 and the pole, image is virtual. Matlab, you can see there is no image on the screen. Just thoda light jo hai wo hai. There is no image. The image is actually inside the mirror, inside the lens. Virtual image, no? So that is how the image looks. The image looks behind the thing actually. You can't get it on a screen. It is behind that. Yeah, thanks for the music. It's a good one. So there. That is what is happening. So there we did the theory part today. So on Friday when we meet, we are going to derive something called lens maker formula. Like what Abhinav was asking, what is the big deal about lens? So you'll get a pretty nice formula. Unlike, this refraction on curved surface, we get something like 1 by v minus 1 by u is 1 by f. We're going to derive that. That is important derivation. And we're going to do complete lens on Friday. So Friday, we are meeting at 5:30. We'll have till maybe 7. I'll give you a 5-minute break and then we'll have it till 8 as usual. We'll have a 2.5 hour class. Okay. So with that, we'll wrap up for the day. Right? The testing is starting from Saturday again. So we'll keep the paper online on Saturday. It will be available till Thursday. So we'll have 4 days of time. So this week it is what? Work per energy, no? Circular motion. And next week we'll have ray optics. Okay. So with that, we'll wrap up for the day. So any doubts, anything, please stay back and ask. Also free to leave. So we have done almost like 34 problems. Please start doing this. You can start doing your PACE booklet or whatever booklet you're doing. Please start doing it. It's time. Because by next Friday, we'll wrap up the chapter. And after that, we'll start off with centromers and